No, we're just going to, well, okay, we're learning 12 lessons. No, I'm just kidding. So see how it says they're all combined together? That's because there's topics in our book. We only need to know a couple things from each of those sections. So we do it all together. But today, all we're going to do is this division problem, okay? So the setup is going to be like what you knew, but sometimes we need placeholders. What I mean by that is, you know how sometimes if like 7 had a decimal or there was a decimal here, you can add zeros afterwards? Since our polynomial has different terms, sometimes we have to add zeros in places where it skipped powers, like it skipped a number place almost. So see how we have an x to the 4th power, but we're missing the x to the 3rd power, and then we have x to the 2nd? We're going to put a 0 in place of the x to the 3rd to kind of hold the place. So I just wrote the polynomials how I would write out a long division problem. The only thing different is I put a 0 term in there so that everything went in order of power. Okay? Now what I'm going to do is I'm going to do what you guys did in long division. I'm not going to concentrate on the whole thing. I'm going to concentrate on the small pieces, specifically the first pieces. In other words, I'm going to ask myself, what would I multiply 2x by to get 4x to the 4th? So it would be 2x cubed. Is everybody okay with that? Why I wrote it over here is because now when I take what I wrote and I multiply it by the divisor out here, how many terms is it really going to have? It's going to have that 2x cubed times 2x, but it's also going to have 2x cubed times minus 1 because 2x cubed has to multiply the whole quantity of 2x minus 1. So I would get 4x cubed, or sorry, 4x to the 4th minus 2x cubed. What do we do in the division process at this point? We subtract. Subtracting this quantity, remember what that means when it's a whole quantity and not just one number, means the subtraction to each of these pieces. So it's like the 4x to the 4th is negative and the 2x cubed is now positive. These cancel out. That should happen every time. That's my goal, just like as you move across a long division problem, right? You shouldn't have more remainder than what you had left. So now I have 2x cubed, and I bring down the next piece. Okay. All right, so what do I ask myself now? How many times does 2x go into 2x cubed? Or in other words, what number do I want to multiply by 2x so that I get a matching 2x cubed right here in this spot? An x squared, okay? But now remember that x squared has to multiply this whole thing. So distribution, x squared times 2x is the 2x cubed I wanted, and x squared 1 is minus x squared. But I'm subtracting that, so it changes all the signs across. Right? So these cancel, which should happen every time, and negative 5x squared plus x squared is negative 4x squared, and I bring down the 2x. Then I do it again. What should I multiply times 2x to get negative 4x squared? Negative 2x. And then I distribute it through. So negative 2x times 2x is negative 4x squared. Negative 2x times positive 1 is positive 2x. This is all being subtracted. So again, that's like changing all of the signs. This time these both canceled out, which means I have a remainder of 0, but I still have a 4 to bring down. Now, 4 is my remainder because the degree of 2x is greater than 4. So, like, I can't multiply by x to, like, negative powers. That's not going to work. So I'm kind of stuck here. So we're going to write our answer as 2x to the 3rd plus x squared minus 2x. Now, we're not going to write the little r with the number next to it. Okay? How else can we express a remainder? As a fraction, right? So if you were dividing by 7, what did you guys get as the remainder in this division problem? 3? So I could have wrote this as 903 and 3/7. What that means mathematically is it went in 903 full times plus 3/7 of a time, okay? So mine's going to say here plus my remainder over what I divided by.